Hello, everyone. I'm Snigdha from Bynry and the host for today's show. I would like to welcome you to a new episode of the Utility Cloud Guide series, where we talk about trending topics and share knowledge with the utility community by talking to leading industry experts. The topic for today's discussion is how design automation tools are changing the water industry landscape. Today, we have Adam Tank with us on the show. He's the Chief Customer Officer at Transcend and has been in the utility industry for 10 years. He has helped water utilities in their digital transformation journey to enhance the customer experience. With Adam today, we will discuss how important it is to use automation tools in the changing water industry. So without wasting much time, I would like to welcome Adam to the show. Hello, Adam.
Hi, thanks for having me.
Hi, yeah. So Adam, my first question to you today is, what do you mean when you say design automation?
So the process of assessing a site for a treatment works or for either water or wastewater, and then of course designing and building that site and commissioning that site is an incredibly challenging process. There are hundreds, if not thousands of hours and a lot of money that's spent figuring out what the best facility that you need to build is. And what we are doing as Transcend is helping streamline that process by automating the conceptual design of the facility. So our software, with just a handful of inputs around your water quality and your treatment type, will design basically the entire plant at a conceptual level instantly. So all of the hours and time and money that's spent in the early phases of a project basically are cleared off the table because it's taken care of by software.
So that's great. Basically, it is increasing the time efficiency and making it more streamlined, the process. That's
right.
Great. So who can benefit most from this design automation process?
What we find is that utilities themselves, as the end customer, either an end customer of ours or an end customer from an engineering consulting firm, they are the ones who tend to benefit most. So by using a tool like ours, very rapidly, they can assess what are the options available to us, what would our treatment works look given a range of potential future scenarios that we have difficulty planning for or predicting. One example of this we could say, traditionally, because this process takes so much time, we may only be able to look at what a treatment works might look like if we have one sort of temperature change, maybe one population model and growth model, and one future regulatory model. But with our tool, you could look at 10 or 20 or 30 different scenarios in the same amount of time. So the end user or the end client, the end customer, the utility gets a much better outcome because you're able to assess so many different options early on and build the best treatment works that's fit for purpose, given a range of potential future scenarios.
Oh, that's great. Like you can do 20 or 30 or 40 more scenarios in one go. That's great. So can you please tell me what are some of the real world examples of this technology that is being used right now?
So our software is being used all over the world. It's designed over 10,000 treatment works to date in over 100 countries. And some of our best use cases are happening in Europe, actually, and in South America. So I'll give you one example in South America. We work with one of the largest privately owned water wastewater companies in Brazil. And they have hundreds of different treatment works that they are oftentimes assessing for new innovative technologies and potential future scenarios that might happen. And they're trying to figure out what's best to build. So in one example of this, they were actually working on acquiring a system in Brazil as part of their business. And by using our software in the proposal process, they were actually able to figure out, here's how much money we need to spend in order to bring this system up to the point where it's effective for the population. And they actually reduced the total dollar amount that they had planned to spend, not only to acquire that system, but what they needed to invest in the system. And instead of that process taking 6 months or a year, it took about 2 weeks through the use of our software. So tremendous benefits in Brazil, and in Europe, we're seeing very similar things. Obviously, not a private market, but they're heavily regulated. And utilities there, in a very similar way, are using it for master planning initiatives. So they're actually bringing in more sustainable technologies because they can evaluate more sustainable technologies as part of their process.
Okay, can you please tell me like what more sustainable technologies? Can you please elaborate more on that?
Yeah, sure. So traditionally, the market for treatment, especially wastewater treatment, is typically what we call conventional treatment technology, something like conventional activated sludge plant. Or you might look at something like a lagoon, an aerated lagoon would be another example, which effectively are just big open pits, or in some cases it's concrete tanks where the water and wastewater is treated. And there have been so many advances in innovation around treatment technologies, new technologies like membrane bioreactors or moving bed bioreactors or fixed film technologies that oftentimes take up far less space, so much smaller footprint, and will either reduce the total capital cost of a project or will reduce the total energy requirements for a project, so the operational expenses for a project. And because the industry typically designs conventional treatment infrastructure, that's what they're used to doing. So that's what they do. But if it's as easy as checking a box for these new innovations, if you check a box, the software not only will design a traditional treatment plant, but it would design a more innovative treatment plant and potentially sustainable treatment plant automatically. So at the end of the process, it's very quick to say, all right, here's a conventional plant, and here's how that compares in terms of capital expenditure, energy expenditure, greenhouse gas, carbon footprint, et cetera, right there. And so you can very easily evaluate, hey, maybe we should look at a newer technology in order to treat this water.
And you also mentioned that there is a significant revenue difference between the conventional and the sustainable energy automation process, right?
That's right. That's right.
So can you please elaborate more on that, like how?
Sure. Sure. So if we're referring to the cost of doing this design work manually or traditionally versus using a software like ours, we typically see it's a tenth or less of the cost, both in terms of actual financial cost, but also time and labor savings. So some of our clients, as an example, on a preliminary design package, will spend over $800,000 USD to complete this type of work. And with our tool, we're doing it for far less actually than a tenth of the cost for each of those. And you're actually getting 10x the value in some cases, or 20x or 30x, because you're able to evaluate so many more options. So for an engineer, what we often hear is, I feel like all I do is copy paste all day. I'm taking my old designs, I'm adding a little bit of flavor to them, and then I'm submitting them to the client. And they oftentimes find themselves quite bored and unsatisfied with that work. So with our tool, not only is it cheaper and more cost-effective to do it our way, but oftentimes it's more fun because the engineers aren't just doing the same old stuff they've been doing for years and years. They now have time to evaluate more approaches, more fun ways of going about it. And we often see that quality of life increases for the people that do this work.
That's great. Like you should enjoy. So that's one of the most important points, I feel. My last question to you is, how can design automation tools help with building digital twins?
Yes, the concept of digital twin is discussed quite a bit in our industry. And I still don't yet feel that there is a single definition of digital twin. So I'll give you what our version of digital twin is, and then I'll share a little bit about how it might help. So a digital twin is the digital representation of a physical asset. So you can imagine, if we're talking about a digital twin in terms of the human body, I love to use this example. You'll probably have 2 arms, you'll have 2 legs, 2 eyes, etc. But that's the physical component. The digital aspect of that would be, what's the data that's generated from the physical asset? So in this case, if we look at your eyes as a physical asset, the data that's generated might be, how well can you see? So do you have 20/20 vision? That would be one example. Or what is the color of your eyes? Okay, your eyes are brown, mine are blue. That would be data that's generated from the physical asset. So when we talk about digital twin in water, we're talking about the data that's generated about or by a certain asset. So as an example, a pump is a physical asset, but the pump efficiency or the pump curve or the throughput of a pump, those would be data that's generated by the pump. So a digital twin is the digital representation or the data that's generated about a treatment works. We at Transcend believe the most critical component of a digital twin is understanding the baseline of how your physical system should. What we mean is you should know based on how your, in this case, treatment infrastructure was designed in the first place, how it should operate. So by using our software, you can actually evaluate what your baseline is today. With what I already have in existence, here is how it should operate. And you have that baseline established, that digital baseline established. But the cool part is once you have that baseline, you can then see how the plant is actually operating in real time. And oftentimes there's a big difference there. So sometimes people will say, all right, here's how our plant is operating, and we think we need to build a brand new, we'll say, set of equipment in order to handle more wastewater. But as it turns out, if you have the baseline, you may not need to do that because maybe the system was designed to actually handle more water, but it's just not being operated efficiently. So before you spend a bunch of money on building a new system, maybe we would consider enhancing the operations first. So that would be an example of how a software like ours can be used in the case of a digital twin to save typically a considerable amount of money. But then also if you're considering investing more, making sure that investment is an efficient investment and a solid investment, you're going to get a good return on that investment.
Yeah, that's quite interesting. The way you connected it with the identical twins in your eyes to like
Yes.
operations going on, that really helped clarify things a lot. I noticed, like you said, there is a big difference between the baseline and the real-time operations. So what do you think are the major contributing factors that contribute to that difference in the baseline and the real-time operation graph?
I think it's a wonderful question, and there's probably quite a few different reasons why that's the case. I know that one reason is that these treatment plants are operating it for decades in many cases. And of course, over the decades, different types of equipment are put into place. Different people come to manage the systems. Different wastewater and temperatures and regulatory requirements that were never planned for when it was built inevitably happen. So you start to put different puzzle pieces inside the plant over time, and you tend to forget, through no fault of anyone, but you tend to forget what the treatment plant was designed to do in the first place. And so there's a reason that there's a difference there, because the people that were responsible for designing and building the plant 20 years later probably retired or they're doing something else. So people tend to forget what was this plant designed to do in the first place. And so I think that's a big reason for why there's a discrepancy. The other reason that I've personally seen, is that a lot of times the plans and the designs and the intent of what the treatment works was there to do in the first place is locked up in paper and in binders, and it's stuck on a shelf somewhere or in the basement, and it's in a dusty box, and those typically get lost, and they certainly don't get updated. So oftentimes when you don't have the most recent and readily available data at your fingertips, you don't know what to do with your system efficiently, how to operate it most efficiently, because you know how it's operating today, and you work on how it's supposed to operate or how it's operating today, and you don't think about how was it originally designed to operate. Bringing that data into a more digital format, we see helps, because you always have this digital twin or representation that's sitting there that can constantly be updated, basically automatically. And so you don't lose all of that information over the years.
Yes, Adam, that was really helpful. It really helped me understand a lot about digital twins, and I really appreciate your initiative towards sustainable energy and all those processes that you're automating. I really would like to thank you for taking out time to come to the show. Do you have any closing remarks for us?
I would say, one, thank you, first off. And then the second is that I hope that we as a water industry can continue to communicate the value of what we do to the world. I feel like not we as Transcend, but we as water professionals, what we are doing is critical to literally the human race all over the world. Without what we do, without water, none of this exists. So we need to tell our stories. We need to jump on shows like this. We need to create our own dialogues and be talking more about the benefits of what we do in society, or no one's going to be thinking about it. And so my dream is that everyone in the world is thinking about the importance of water, and they appreciate the value of the services that we provide as a water industry to the community. So I would just encourage people, talk about your jobs, hire more people into the water sector, think more innovatively, and it'll be better for everyone.